In this video, we will look into some well-known semantic lexicons that were built mostly for English, but are being built for other languages as well, just like WordNets. We will describe 4 most commonly used lexical resources that make use of the 2 alternative approaches to semantic roles representation. In this slide, we have a list of 4 resources that we will look into more detail. Jackendorf has developed Lexical Conceptual Structure, the resource that attempts to capture the lexical meaning of predicates in terms of a set of primitive predicates to define generalizations across predicates. VerbNet, developed by Kieper-Schuller in 2005, represents an extension and refinement of 11 verb classes. It is located directly at the boundary between syntax and semantics. FrameNet is a lexicon in the frame semantics paradigm developed by Fillmore in 1976 that uses semantic roles that are specific to a general semantic idea called a frame. PropBank is a verb lexicon specifying semantic predicate and role annotations on top of the Penn tree bank. It uses both proto-roles and verb-specific semantic roles. Lexical Conceptual Structure was developed by Dorr in 2001 at the University of Maryland. It is a lexicon for English that attempts to capture the lexical meaning of predicates in terms of a set of primitive predicates such as goes, go, inspired by physical motion, to define generalizations across predicates. The LCS database contains lexical conceptual structures organized into semantic classes that are a reformulated version of those in Beth-Levin, English verb classes. The LCS database was hand-tagged with WordNet on a per-class basis, using the 1.6 version of WordNet. The resulting database was further extended to include 26 new classes and adding 3,000 WordNet-tagged verbs. It contains handcrafted lexical entries for 4,432 verbs. LCS is a directed graph with a root. Each node is associated with certain information, including a type, a primitive, and a field. The type of an LCS node is one of event, state, path, manner, property, or thing. There are 2 general classes of primitives: closed class or structural primitive, for instance goes, go, be, to, and open class primitives or constants, for instance reduced, textile, /ingly. Suffixes such as plus, plus ed, plus ingly are markers of the open class of primitives. Primitives have examples of fields including locational, possessional, identificational. An LCS captures the semantics of a lexical item through a combination of semantic structure, specified by the shape of the graph and its structural primitives and fields, and semantic content, specified through constants. The semantic structure of a verb is something the verb inherits from its 11 verb class, whereas the content comes from the specific verb itself. So, all the verbs in the cut verbs change of state class have the same semantic structure but vary in their semantic content. For example, chip, cut, sew, scrape, slash, and scratch. LCS dictionaries for other languages may be handcrafted or produced partially automatically. Here we have an example, sentence represented in LCS. The events expressed by the verb throw have primitives goes and go, while path has primitive to and place has primitive at, that belong to a closed class of structural primitives. It also has types entity specified as thing, where John is agent, toy is theme, and across the playground is goal. VerbNet is another lexical resource, a hierarchical domain-independent, broad-coverage verb lexicon for English that links each verb to both WordNet and FrameNet entries. Each VerbNet verb class contains a set of syntactic descriptions or syntactic frames depicting the possible surface realizations of the argument structure for constructions such as transitive, intransitive, prepositional phrases, etc. Semantic restrictions such as animate, human, organization are used to constrain the types of thematic roles allowed by the arguments, and further restrictions may be imposed to indicate the syntactic nature of the constituent likely to be associated with the thematic role. Syntactic frames may also be constrained in terms of which prepositions are allowed. Each frame is associated with explicit semantic information. The figure on the slide shows the verbnet entry for the class hit. As you can see, we have an example, Paula hit the ball. The syntactic representation very similar to the one we saw in valency lexicons, agent, verb, patient, and then semantics, where agents caused the action during her directed motion. There is contact with the patient involved and the manner of the action is forceful. The members of the class are bang, bash, hit, kick, etc. The roles and restrictions include an agent with internal control, the patient, which is concrete object, as well as instrument. Each verb argument in VerbNet is assigned one, usually unique, thematic role within the class. The lexicon represents an extension and refinement of the work of Levin, as we mentioned before, who summarized sets of verb classes defined by shared argument realizations. There are 23 thematic roles: actor, agent, asset, attribute, beneficiary, cause, location, etc. It contains 5,257 verb senses and 3,769 lemmas. It is located directly at the boundary between syntax and semantics. On the syntactic side, the lexicon contains syntactic frames, field syntax, with selectional restrictions of verb arguments, field roles. The semantic side is based on intersective Levin classes, a refinement of Levin's original theory, and defines a hierarchy over verb classes, generally not exceeding a depth of 3 levels. Its field class. It assumes a small set of abstract, semantically motivated thematic roles, field roles. For selected meaning aspects, VerbNet provides fine-grained definitions in a decompositional style, using conjunctions of semantic predicates to characterize pre- and post-conditions of the event, as well as temporal and aspectual properties. Is field semantics. And here we have another lexical resource, FrameNet, developed in 2003. It is a lexicon based on the frame semantics theory deriving from the work of Charles Fillmore from 1976, that groups not just verbs but also nouns and adjectives into semantic classes called frames that correspond to abstract situations or events. More than 200,000 manually annotated sentences linked to more than 1,200 semantic frames provide a unique training data set for semantic role labeling, used in applications such as information extraction, machine translation, event recognition, sentiment analysis, etc. For students and teachers of linguistics, it serves as a valency dictionary with uniquely detailed evidence from the combinatorial properties of a core set of the English vocabulary. Frames are networked using several relations. It is based on the corpus analysis, British National Corpus examples. It has many primitives and many semantic roles, which are separated into core roles, which are frame-specific, and non-core roles, which are more like the arg-m arguments in PropBank that we will look into later, and express more general properties of time, location, and so on. The coarse-grained semantic classes, frames, typically cover a number of predicates and provide only a limited definition in terms of their sets of semantic roles. FrameNet also codes relationships between frames, allowing frames to inherit from each other, or representing relations between frames like causation and generalization among frame elements in different frames can be represented by inheritance as well. For instance, there is a cause change of position on a scale frame that is linked to the change of position on a scale frame by cause relation. Due to its primarily semantics-oriented structuring principles, the FrameNet classifications established for English have been successfully transferred to different languages, though not without need for language-specific adjustments in the inventory of frames and roles. Since the frames are basically semantic, they are often similar across languages. For example, frames about buying and selling involve the frame elements buyer, seller, goods, and money, regardless of the language in which they are expressed. So other framelets are being developed for Spanish, French, Japanese, Chinese, German, Brazilian Portuguese, Swedish, and Korean. In the frame semantics theory, the meanings of most words can best be understood on the basis of a semantic frame, a description of a type of event, relation, or entity, and the participants in it. For example, the concept of cooking typically involves a person doing the cooking, cook, the food that is being cooked, something to hold the food while cooking, container, and a source of heat, heating instrument. In the framenet, this is represented as a frame called apply heat, and the cook, food, heating instrument, and container are called frame elements. Words that evoke this frame, such as fry, bake, boil, and broil, are called lexical units, LUs, of the apply heat frame. They can be verbs, for instance, fry, bake, boil, broil, steam, steep, stew, or nouns, stewing, toasting, frying, broiling, baking, etc. And here we have examples of apply heat frame, such as Sally fried an egg in butter, or Kate blanched the broccoli by throwing it into a pot of boiling water. Some frames are more complex, such as revenge, which involves more frame elements: offender, injury, injured party, avenger, and punishment. The lexical units of the revenge frame are verbs: avenge, revenge, retaliate, get back at, pay back, get even, but also nouns: revenge, vengeance, retaliation, retribution, reprisal, as well as adjectives: vengeful, retaliatory, retributive, in revenge, in retaliation, and some idioms as well: take revenge, exact retribution, etc. In the simplest case, the frame evoking word is a verb, and the frame elements are its syntactic dependents, as in the example above, where I is the subject of the verb get even, while you is the object, and for this is a prepositional phrase. But lexical units can also be event nouns, such as retaliation in the revenge frame. The lexical entry for each lexical unit is derived from corpus examples, annotations, and specifies the ways in which frame elements are realized in syntactic structures headed by the word. Framenet annotations are sets of triples that reserves the frame element realizations for each annotated sentence, each consisting of a frame element name, for example food, a grammatical function, say object, and a phrase type, say noun phrase. Most of the annotations are of separate sentences annotated for only one lexical unit, but there are also a collection of texts in which all the frame-evoking words have been annotated. The overlapping frames provide a rich representation of much of the meaning of the entire text. The FrameNet team have defined more than 1,000 semantic frames and have linked them together by a system of frame relations, which relate more general frames to more specific ones and provide a basis for reasoning about events and intentional actions. Prop bank is a corpus of text annotated with information about basic semantic propositions. Predicate-argument relations were added to the syntactic trees of the Penn tree bank. English prop bank labels all the sentences in the Penn tree bank. The Chinese prop bank labels sentences in the Penn Chinese tree bank. Prop bank has also been mapped to VerbNet and FrameNet as part of Semlink, mapping together prop bank, VerbNet, and FrameNet, and one can browse a combined representation of those three resources at the Unified Verb Index. NumBank, developed by Myers and co-authors in 2004, extends the approach to deverbal nouns. PropBank and NumBank annotate coarse-grained word sentences called role sets. PropBank style annotations often remain close to the syntactic level. Because of the difficulty of defining a universal set of thematic roles, the semantic roles in PropBank are defined with respect to an individual verb sense. It requires all arguments to a verb to be syntactic constituents, and different senses of a word are only distinguished in the differences bear on the arguments. Whereas roles in the framenet are specific to a frame, roles in PropBank are specific to an individual verb. The PropBank semantic roles can be useful in recovering shallow semantic information about verbal arguments. Each sense of a verb has a specific set of roles in PropBank, which are given numbers rather than names. So we have arg0, 1, 2, and so on. The argn labels are arbitrary labels. However, PropBank tries to use them consistently across verbs. In general, arg0 represents the proto-agent, agent or the argument most likely to be the subject in active voice, and arg1, the proto-patient, is a team or patient or the direct object of a transitive verb in active voice. It can also be the subject of a verb in passive voice or the subject of an intransitive verb. arg0 and arg1 correspond to Doughty's proto-agent and proto-patient and thus share meaning across predicates. The semantics of the other roles are less consistent, often being defined specifically for each verb. There are some generalizations. The arg2 is often the benefactive instrument, attribute, or end state, while the arg3 is usually the start point and the arg4 the end point. PropBank also has a number of non-numbered arguments called argms, which represent modification or adjunct meanings. These are relatively stable across predicates, so aren't listed with each frame file. Data labeled with these modifiers can be helpful in training systems to detect temporal, location, or directional modification across predicates. Some of the argms include when, where to or from, how, why, secondary predication, etc. And here is a PropBank entry for one sense of the word abandon. Such PropBank entries are called frame files. There is arg0 abandoner, arg1 directional, thing abandoned, left behind, and arg2 prd marker of secondary predication, attribute of arg1. We have two examples. One is typically transitive, and they believe the big board under Mr. Phelan has abandoned their interest, with arg0 being the big board, argm under Mr. Phelan, and relation abandoned arg1 their interest. Then we have an example with attributes. John abandoned his pursuit of an Olympic gold medal as a waste of time, with arg0 being John, relation abandoned arg1 his pursuit of an Olympic gold medal, and finally arg2 as a waste of time. Resources that follow the model of PropBank have been developed for Chinese and Korean, although the syntactic nature of PropBank style roles makes the reuse of English role definitions for other languages difficult. FrameNet, VerbNet, and PropBank are all built with the semantic role labeling in mind. Attempts to make the predicates in a sentence, usually verbs, but sometimes also nouns or adjectives, and identify the roles using one of these representations. Here, we will look into one final example to see the similarities and differences of these three lexicons. Given the ingestion sense of the verb eat in the sentence, Mary ate the soup with a spoon, the representative representations for each would be: in FrameNet, Mary would be ingester, ate is a predicate, the soup is ingestible, and spoon is an instrument. In VerbNet, Mary is agent, and the soup is patient. While in PropBank, Mary is just arg0, the soup is arg1, and the spoon is argm, representing manner. While PropBank appears to be least useful, its more general representation makes it more practical to train an accurate semantic role labeler. Additionally, PropBank has a set of frame sets that essentially define what the args are in a more VerbNet FrameNet way. When originally starting PropBank, Martha Palmer had almost considered backing off all the way to the notion of proto-subjects and proto-objects, but ultimately settled on the PropBank representation after lots of refinement and several rounds of discussion. And here finally you have the references describing the semantic lexicons we just mentioned in this video.